first. There we go. Okay, happy birthday, Renee. This is for you. All right, so let's see. We listed out a few terms, and then I found the 10th term, so I got that covered. And then nth term. So that means find a formula where n is one of these blue numbers here. So I could just plug in the number 10 for the 10th term, and out pops 29. So the trick on these guys right here is because of the 3, 3, 3 added, the formula has to have in it a 3 times n. And then the question is, do I have to add or subtract anything? So plus or minus something maybe. And so then we just check to see if that works. That's one way to do it. The book gave a formula. It's a little bit different. So if I plug in n equals, let's say 3, I get 3 times 3 equals 9. I wanted it to be 8. So I could take away 1 to adjust it, and now I have my 8. Okay, so now I think the formula is 3n minus 1. I'm going to check again. N equals, let's say, 4. So if I take 3 times 4 minus 1, that's 12 minus 1, or 11, and now that checks. So then I can say the nth term formula is 3n minus 1. And maybe I'll circle that. So I've got my different answers here in 2 different ways there, and then my continuing the pattern. It's a good idea to write stuff down for every single problem, and then if you want at the end of the time test, you can submit pictures of any work you have for me. And I'll show you a couple ways to do that. All right, 1, 4, 16, 64. 1, 4, 16, 64. Let's see what we got there. 1, 4, 16, 64. Did I copy them right? 1, 4, 16, 64. Looks good. So next thing, I would do the same thing I did before. I'd ask myself, what's 4 minus 1? What's 16 minus 4? And what's 64 minus 16? Oh, that one's harder. 48, I think. 48 plus 16. 8 plus 6 is 14. Carry the 1. 4, 5, 6. Yeah, 48. Not sure I see a pattern there. Maybe it's the next set of differences that works. So 12 minus 3 is 9. 48 minus 12 is what, 36? Looks like a dead end to me. So I'm going to try something else. Let's list the numbers again. 1, 4, 16, 64. Okay, so let's see. Subtracting consecutive terms was one trick. The other was dividing consecutive terms. Like, what's the constant multiple? 4 divided by 1 is 4. So 1 times 4 gets me there. 16 divided by 4 is 4. Oh, this is looking promising. And let's see, if I take 4 times 16, do I get 64? Yes, I do. All right, I found a pattern. Multiply by 4. So again, this is a consecutive ratio between terms. 64 divided by 16 is 4. 16 divided by 4 is 4. 4 divided by 1 is 4. So there's a constant multiple between terms. So I can just keep multiplying by 4. So then the next term is 64 times 4, which would be what? 256 maybe? And this is this is definitely a good time for a calculator to make sure I'm getting this right, because I'm running out of brain power to do that. I think it's 1,000 something. So calculator time. Spreadsheet would also be another good tool here. So let's see, we were at last at 64 times 4 is 256, I got it right, times 4 again, 1,024, so I'm moving along here. There, 1,024, and then it said to list a few terms, so I usually do 3 for a few, a couple would be 2. So times 4 again, 4096. Now they want the 10th term, so I could keep multiplying by 4. So this is the first one, the second one, the third one, the fourth one, the fifth one, the sixth one, the seventh one. So 8, 9, 10. If I multiply by 4 3 more times, that should give me 8, 9, and 10. So I'm just going to skip over to the 10th one, and then we'll make a formula to double check it. Times 4, times 4, times 4. The 10th one should be 226,144. 262,144. Get that right. Always double check what you type and what you write. 262,144, yeah. All right, so next is we go for a formula, whereas the arithmetic or linear problems have a constant addition which leads to a multiplication. This is a constant multiplication which leads to an exponent. So the formula is going to have something to do with 4 to the power n. Now, with the addition problems, we add or subtract something. With the multiplication problems, we're going to end up multiplying or dividing by something. So I'm just going to put, we're going to be multiplying by something to adjust if it doesn't work. That's the trick I used before on this. And the book goes over a slightly different way to do this. And I can show that too in a sec. So then I check, see how my formula is doing. So let's see, if n is equal to 3, then my formula says to take 4 to the 3rd power. And 4 to the 3rd power is 4 times 4 is 16 times 4 is 64. Oh, I wanted it to be 16. I'm close. I'm 4 times too big. So I think to tweak this formula, I'm going to divide that by 4. So what's 64 divided by 4? That would be 16. So let's check to see if this is working, because that is what I want. Let's check that for n equals, let's go with the 5th term. So my formula now says take 4 to the 5th power divided by 4. And so I'm going to ask my calculator what that is. What is 4 raised to the 5th power, then divide by 4? I get 256, and that is what the 5th term is supposed to be there. So I got it correct, 256. So now I'm just going to reiterate my formula. I could say it's multiplying by 1/4 or dividing by 4. So either way is okay. So that is my formula. And I want to double check that, see if it gives me the same 10th one. Calculator, so find ways to double check wherever you can. 4 raised to the 10th power, and then, oops, that's not the raised to the power button. There we go, raised to the 10th power, and then divide that by 4, and I get 262,144. Okay, so it looks like this formula is working out. So there's another version of this I talked about in class, where if you recognize that this is geometric, then the formula for this is always going to be what's called A times R to the power n minus 1, where A is the first term, and R is what we call the common ratio. So for my problem over here, the common ratio was 4, because 4 divided by 1 is 4, 16 divided by 4 is 4, 64 divided by 16 is 4. So my R is equal to 4. My first term is equal to 1. So according to this formula, the answer should be 1 times 4 to the power n minus 1, which cleans up to just be 4 to the power n minus 1. And we can test that to see if it works. Some calculators are going to need parentheses to do that. So if I test that for, say, the 5th term, 1 times is kind of boring, so I'm just going to go 4 raised to the power, There we go. And then my calculator needs parentheses for the power. And then I would type in 5 minus 1, enter, and there's my 256. It works. All right, so a couple ways I got the formula. So sometimes formulas can be written in different ways, and that's okay. Question on that one. Can somebody say something so I can see if my speaker works? Anyone?
No, I think I'm good on that one.
Okay, thank you very much. Appreciate it. All right, we're humans working together. So let's try the next one. Let's see, 2, 6, 18, 54. 2, 6, 18, 54. 2, 6, 18, 54. And we want to try and continue this. That looks like they're not the same distance apart. So I'm going to skip the whole add going up. From 2 to 6 is 4. From 6 to 18 is, I guess I'll do it just to be consistent. 2 to 6 is plus 4. 6 to 18 is plus 12. 18 to 54 would be, what is that? That would be 26? No, 36.
36, yeah.
36. All right, again, calculator is your friend on this. Don't do too much math in your head. As powerful as that feels, it's dangerous on the test. All right, so I just put myself in danger there. Try not to do that again. 4, 12, 36. I'm not sure I see a pattern there, so I'll try again. 12 minus 4 is 8. And then 36 minus 12 is 24. Not so sure about that. Feels like a dead end without another term to go by. All right, so let's go to the other method. 2, 6, 18, 54. This time we're going to divide. So 6 divided by 2 is 3, so it's a times 3. 18 divided by 6, oh, that's 3 too. Times 3. And 54 divided by 18, that one I'm going to have to check with my calculator. 54 over 18 is 3. 3 is the magic number. Oh, wait, 3 is a magic number. Times 3. All right, so it looks like we keep multiplying by 3 to continuous. So let's see, 54 divided by 3 would be 150 plus 12, which is 162. All right, and then we just keep multiplying by 3. So what that would be, 3 times 2 is 6. 3 times 6 is 18. Carry the 1, 486. And then I think it might be calculator time. 8, carry the 1. 5, carry the 2, 1,458. Anyone else get that? I just totally messed that up. Again, I'm doing dangerous things. I should whip out a calculator.
I got that too, and I used a calculator.
Okay, so let's just double check. Times 3 equals, times 3 equals, times 3 equals. Okay, so we're doing all right. And that takes us up to what I think the 7th term. So we could keep multiplying to get the 10th term, but we're looking for a pattern. I think we're ready to just jump right to the pattern and then get the 10th term. So that's number 1, number 2, 3, 4, 5, 6, and 7. We need to get the 10th one, and then we want the nth one. So I'm going to jump right to the nth one. So the formula I gave previously said to take the first term 2 and multiply by the base 3, that common ratio, to the power n minus 1 should be the formula. We should check that just to make sure. So I'm going to check it on n equals 4 before I do n equals 10. Always checking on something you know to be true, which was one of the given numbers. So I'm going to check n equals 4. So the answer should be 2 times 3 to the 4 minus 1. I think I wrote that correctly. 2 times 3 to the power. My calculator needs parentheses for the power 4 minus 1. I could just in my head say 4 minus 1 is 3. That would have been okay. And I get 54, which is what I was hoping to get on the fourth term. So this formula does seem to work. So now I can find the 10th one by just plugging in 10. So it's going to be the result of 2 times 3 to the 9th power. 10 minus 1 is 9. That one I feel safe in my head. 2 times 3 to the power, come on power, 9. 10th term should be 39,366. Get that right? Okay. And then either I should explicitly write some stuff down or start highlighting things. So this is my continued pattern there. Here is my 10th term and my nth term formula. All right, making progress. Next. 1, 4, 5, 9. 1, 4, 5, 9. 1, 4, 5, 9. Let's see. 1 to 4 is plus 3. And I have a plus 1. And then I have a plus 4. Eek. That's weird. So that doesn't help. 1, 4, 5, 9. If we divide them, let's see, here I would multiply by 4, but here I would multiply by not 4, that's for sure. All right, what other tricks do we have up our sleeve? 1, 4, 5, whoa, my pen is freaking out. Sure is user error. 1, 4, 5, 9. What could come next? 1 and 4 is 5. Oh, check this out. 1 plus 4 gives me 5. 4 plus 5 gives me 9. So I think 5 plus 9 is going to give me 14. This is a Fibonacci sequence. So starting with 1 and 4, add the 2 previous terms. Repeat. Okay, so starting with 1 and 4, to get this term, 1 plus 4 is 5. To get 9, 4 plus 5 is 9. To get 14, 9 plus 5 is 14. So the next one is going to be 14 plus 9, or 23. And then 23 plus 14 is 37. And then 23 plus 37 is 60. And here, without whipping out a spreadsheet, I pretty much have to keep counting. 1, 2, 3, 4, 5, 6, 7, 8, 2 more to get to 10th term. So 60 and 37 is 97. 97 and 60 is 157, right? Yep. So I've got the 10th term right there. All right, so I continued my pattern. I got the 10th term. This, in words right here at the bottom, is the nth term formula. It describes how to keep going. So this is what I call the recursive formula before. To get one term, you got to know something about previous term or terms. And it's okay. Sometimes the formula is just words.
I can't see the bottom of the screen where it shows the nth term formula.
Okay, so the Zoom stuff is probably in the way. Let's see, how can I move that up? I will just rewrite it up above so you can see it. So the nth term in this case is just an explanation that I spoke and then wrote. So starting with 1 and 4, add the two previous terms. Previous, did I spell that right? I think so. Oh, previous, there we go. And repeat. So you just explain to somebody how to do it. So, and this is what we call a recursive formula. The other formulas we found so far are called explicit formulas, meaning you plug in 10 and out pops the answer. Here, the only way to get the 10th term is to know the 9th and the 8th, which means you need to know the 8th and the 7th, and the 7th and the 6th, and so on down the line. So that would be the nth term formula right there. So a similar formula for one of the previous examples, like say this one right here for a recursive formula. So nth term recursive formula would be to say multiply the previous term by 3, starting with 2. So a slightly different wording, but I just say, hey, multiply by 3 to get the next term, or take the previous term times 3, but we eventually have to know where to start. So in this case, I would start with 2. And I only need to know one term to start here. So this would be an alternative answer for the nth term, instead of this explicit formula over here. So something like where you say to do something to the previous term, that's recursive. Spreadsheets do that great. Anytime you are able to plug in a value for a letter, that's called an explicit formula. And those are nice too, instant gratification. Spreadsheets do those okay too. Okay, so I'm gonna pause or stop the recording.